Vanakkam one and all. We will discuss problem number 7 of exercise 5.1. So here they have given us one function and they are asking for the points of discontinuity of the function. So the function has been defined like this. So if we draw one real line, it goes up to infinity, here center, neutral 0, and here it goes up to minus infinity. So 1, 2, 3, it's go and so on. Here it is minus 1, minus 2, minus 3 and so on. So when the values of x less than minus 3 and equal to minus 3, when the values of x less than minus 3 and equal to minus 3, in that case the function is mod x plus 3. So this expression, this one can be written as minus 3 comma up to minus infinity. And when the values of x lies in the interval, which means greater than minus 3 and less than plus 3, in such cases the function will be minus 2x. So we can write it as open interval, because here we are not considering minus 3, the number minus 3 and the number plus 3, and we'll consider the remaining all numbers which are in between those two extreme numbers, I mean minus 3 and plus 3. That's why I have mentioned open bracket here. And then when the value of x is equal to 3 and greater than 3, so in this case up to it may go up to infinity, right? So there the function has been defined as 6x plus 2. So here this interval can be written as closed interval 3 comma infinity. So we are uniting all these subsets of real numbers. So as a result we are getting the entire real number. So now we can say the domain of the function, function is R. Okay, so now if the values of x for all x less than minus 3, don't consider minus 3, please consider the numbers which are less than minus 3. So for that the function is mod x plus 3. So here we know mod function is continuous function and 3 is a constant function. So f of x is equal to sum of two continuous functions. So we can say sum of two continuous functions. Since mod x is continuous for all x less than minus 3 and 3 is a constant function, again it will be continuous for all the elements for all x less than minus 3, and the sum of these two continuous function will be a continuous function. We can say function is continuous. As it is continuous for all x less than minus 3, we can say there is no point of discontinuity in this segment. Okay, and similarly we'll consider that elements for all x greater than 3. For all x greater than 3, we'll have f of x as 6x plus 2, which is a polynomial. In particular it is linear polynomial. So that polynomial functions are continuous, which implies polynomial. Since f of x is a polynomial function, so polynomial, we can say f of x is continuous for all x greater than 3. So now we'll check the continuity of the function at minus 3 and plus 3. Okay, and within this interval, if you choose any point, -2, -1, 0, 1, 2, and in the neighborhood of 2, we'll get the functional value as -2x. For all that, the function is continuous only. Okay, so for all x belongs to this interval, f of x is equal to minus 2x. Since again it is a polynomial function. Okay, it's a polynomial. So, which implies f of x is continuous for all x belongs to the open interval -3 comma +3. So as I said, my open interval, it means it says -3 and +3 are excluded. The boundaries are excluded. Now we will check the continuity at x equal to -3. We'll check at x equal to -3. So at x equal to -3, what about the functional value? Functional value when x is equal to -3, the function is mod x plus 3. Mod x plus 3, right? So we are taking x as -3 plus 3. So mod function, when the input is in minus, we will write minus x. So here minus x plus 3 will come. So -3 plus 3, which is 6. So the functional value is 6. So in the previous I have explained about mod function in one of the videos. I'll give the link of that video in the description. So now we have got the functional value as 6. Now we'll check the left hand and right hand limit at 3. So limit x tends to 3 -3 from left hand neighborhood. So left hand neighborhood means this part. So what about the function there? Mod x plus 3. So mod x plus 3 will be the function. So mod x plus 3. Now according to the definition of mod, we can write, anyways, if you replace x as 3 minus h, -3 minus h, will end up with the same solution. So I am not going to introduce h here. Okay, directly I will apply limit. So mod here when we apply -3 plus 3, and according to the definition minus, here it is -3 plus 3, which is 6. Now we will calculate right hand limit. Limit x tends to -3. The x values are approaching -3 from right hand neighborhood. So in right hand neighborhood, okay. So in right hand neighborhood means we'll have -2x as a function. So -2x is a function. So -2 into apply x as -3, will get +6. So here left hand limit equal to right hand limit, and these two are equal. As these two are equal, we can say the function's limit exists, and the limit is equal to the functional value. So we can say f of x is continuous at x equal to -3. Now we'll check the continuity of the function at x equal to +3. Now we'll see at x equal to +3. So at x equal to 3, the function has been defined as 6x plus 2. So 6 into 3 plus 2, which is 18 plus 2, that is 20. So the functional value at 3 is 20. Now we'll calculate left hand limit. Limit extends to 3 from left hand neighborhood. So in the left hand neighborhood of 3, we have the function is -2x. So we'll write -2x. Now -2 into x is 3. We'll get -6. So here itself we can say the limit is not equal to, okay, left hand limit, anyways the limit is not equal to the functional value, but still we can calculate the right hand limit too. So limit x tends to 3 from right hand neighborhood. Again in the right hand neighborhood, here it is, the function is 6x plus 2. So 6x plus 2, 6 into x is 3 plus 2. 18 plus 2 will get, which is 20. But left hand limit is not equal to right hand limit. So we can say f of at x equal to 3, the function is discontinuous. So the point of discontinuity is 3. And in the remaining parts, the function is continuous. Or else we can rewrite it as the function is continuous at the entire real number except at the point 3. Thank you.